This is a drilling rig. Its job is to drill a hole in the ground. Of course, it's a special hole. It's designed to tap oil and gas that lie thousands of feet under the ground. The people who work on rigs are special too. It's not an easy job. You work outside in all kinds of weather, the work shifts are long, and you can get pretty grubby. But if you take a liking to it, you may not want to do anything else. One good thing about working on a rig is that you're part of a team. In fact, a lot of people call the rig crew the rig team. Everybody on the rig, and in the office and yard for that matter, is part of the drilling team. If you've never worked on a rig, it can look mighty complicated. And you know what? It is. But stay with us. We'll help you understand it. For instance, we'll show you some of the equipment that makes a rig work. We'll fill you in on some of the people you'll work with. You'll see some things you need to know to do your job safely and correctly. And we'll show you some of the gear you'll need on the job, as well as job safety considerations. So, sit back, watch, and listen, and you'll learn some helpful information. So to start, let's take a closer look at the rig. Your rig won't be exactly like this one, but it will be similar. All rigs require the same basic equipment to enable them to drill. To make it easy, we'll divide rig equipment into 4 systems. One system is the rotating system. The rotating system turns the drill stem and the bit to drill the hole. The second system is the hoisting system. The hoisting system suspends the drill stem and bit in the hole. The third system is the circulating system. The circulating system pumps drilling fluid down the drill stem and back to the surface. The fourth is the power system. Big engines power the other systems. To tell you more about rig systems, here's the leader of the rig floor team. He's the driller.
Rotating bit. We start where we have a bit in the bottom. It's connected to the drill string, coming up to the rotor table. Connected by a drive bushing. Then it's connected by a Kelly. And then the Kelly is connected to the Kelly swivel. Drive bushings are connected to the rotor table, which turns the pipe to your right.
The rotating system is the heart of the drilling process. The bit is the primary tool in this system. As the bit rotates, it cuts the rock to drill the hole. A special fluid called drilling fluid goes down the drill stem and out of small openings or jets in the bit. The fluid cleans the bottom of the hole and carries the cuttings away from the bit and back to the surface. Here is a rotary table and Kelly. This is one of 2 kinds of surface rotating equipment. The Kelly is usually a 40-foot length of pipe. It screws into the top of the drill stem. The Kelly isn't round. Instead, it has flat sides. The flat sides of the Kelly fit into a corresponding opening in the Kelly drive bushing. As the rotary table turns the Kelly drive bushing, the Kelly turns, and thus the attached drill stem and bit also turn. The top of the Kelly screws into the swivel. The swivel allows the Kelly to rotate. The swivel also has a passageway for drilling fluid to flow from the surface to the pipe and bit below. The second kind of rotating system is a top drive. The top drive has a powerful built-in motor. The motor's drive shaft screws directly into the drill stem. A top drive replaces the Kelly and the Kelly drive bushing. The top drive also suspends the weight of the drill stem as it rotates the stem. At the same time, drilling fluid flows through the built-in swivel and into the drill stem and bit below. A top drive allows the crew to drill ahead without having to stop as often to add more pipe as the hole deepens. It can therefore speed up the drilling process. Thus, top drives are a popular way to rotate the drill stem and bit, but they are expensive. Above the top drive, or the Kelly, is a large hook and the rest of the hoisting system. The hoisting system suspends the enormous weight of the drill stem in the hole. The hole could be thousands of feet deep and require tons of pipe before the well is completed. The hoisting system also lowers and raises the drill stem.
We're using what we call a drawworks that's diesel powered. We're using this to trip in and out of the hole, and we set all of our drill pipe back in the derrick with this. It consists of a crown, a block setup, and a 1 inch and an eighth drilling line on this particular rig.
The hoisting system includes the mast or derrick, as it is usually called, the traveling block, the crown block, the wire rope drilling line, and the drawer works. A mast or derrick is one of the most distinctive things about a drilling rig. It is a structural tower that suspends and supports the hoisting system and pipe. Notice, too, that the derrick and rig floor rest on a substructure. The substructure supports the derrick, and the draw works if it's on the rig floor. Two blocks are in the derrick. The one at the top is the crown block. The other is the traveling block. It travels up and down the derrick. The drilling line suspends the traveling block and allows it to move up and down. The drilling line is spooled around a rotating drum inside a large hoist. This hoist is the draw works. The drum turns to reel in the wire rope and reverses direction to let it out. Together, the derrick, the crown and traveling blocks, the wire rope drilling line, and the draw works work to suspend and move thousands of pounds of drill stem in and out of the hole.
Circulator system. We use these two big pumps behind me, which pumps the mud, sucks it out of the tanks. We'll pump it up to the Kelly swivel, down the Kelly through the drill pipe, come out the bit through the backside, come back up, picking up the cuttings at the same time. We'll come up to the blow operators, through the flow line to the shakers. Which the shaker separates the cuttings and the fluid. Fluid dumped back in the tanks. And then we'll repeat the same process all over again.
The drilling fluid, or mud as it is often called, is usually a liquid. Steel mud tanks, or pits, hold the mud on the surface. These particular mud tanks hold about 42,000 gallons, or about 1,000 barrels. In the oil field, we usually measure capacity in barrels. A barrel is 42 gallons. Water, or oil, usually forms the base of the mud. The rig crew adds special materials to the liquid. The materials give it special properties that help drill the hole. Once the mud's ready, one or more big mud pumps pump it down the hole. The heavy-duty mud pump pumps the mud from the tanks to the swivel, through the Kelly or the top drive, down the drill stem, and to the bit. When the mud exits the bit, it goes back to the surface carrying the cuttings made by the bit. Once the mud comes back to the surface, it flows over a shale shaker and through other pieces of equipment. The shaker and other equipment remove virtually all of the sand and rock cuttings from the mud. Then the clean mud goes back down the hole again. It goes through special lines and pipes, back up a pipe on the derrick, into the swivel, and back down the drill stem. The circulating system is essential to rotary drilling for many reasons. For one thing, the mud brings the bit cuttings to the surface. If the mud wasn't there to remove the cuttings, they'd clog up the hole and drilling would stop. Mud also supports the walls of the hole to keep it from collapsing. Without circulating mud, we couldn't drill with a rotary rig. So far, you've seen the rotating system, the hoisting system, and the circulating system. But what powers this equipment? What drives the rotating, hoisting, and circulating systems? Usually diesel engines power the rig. The engines are diesel because diesels deliver more turning force or torque than gasoline engines. Plus, diesel fuel is safer than gasoline, is not as volatile. A rig can have from 2 to 4 engines, depending on the rig size and the power it needs to drill efficiently. Okay, the engines put out power. But this power has got to get to the equipment that needs it, like the mud pumps or the drawworks. Some rigs use a machine called a compound to transfer engine power. Under the steel guards, where you can't see them, big sprockets and chains make up the compound. The chains and sprockets send the power where it's needed. The most common way to transfer power is electrical. Instead of a mechanical compound, the rig engines drive generators. The generators make electricity. This electricity goes to powerful electric motors. The motors power equipment like the mud pumps and the drawworks.
What we have here is a rotary table, Kelly, our swivel, and blocks. And this is what we're using to drill with and to trip out of the hole with. It's all run from the drawworks. This is what we're considering our circulating system. We're taking mud from these steel pits into our pumps, it's sending it down a manifold, and then from there it's going up a standpipe through this Kelly hose, going down the drill string and through the bit. Then this fluid is going to come back up the backside of the hole, through the flow line, through these shakers which will clean the fluid, and then the fluid will go back into these steel pits and then start all over again. This is the drawworks that's giving us the power to handle our pipe. It's got a drilling line on it that goes all the way up over the crown. It's strung through these blocks. That's what will suspend this drill string and let us trip it in and out of the hole. We can trip it out and put it in the board, rack it on the floor, and use it to make connections with also. On this rig, we've got 4 sets of motors